I think there's still litigation for that divorce unless that's resolved because he's going after her for a ton of money. He's trying to, even though he's prenup and everything, he's trying to go after her from the deed saying she married him basically to stupidly and
Yeah.
maybe that's my southern mindset, but if you're not
That's
not
easy.
easy to go
Well,
after a
that's
woman.
interesting.
Yeah,
enough.
2001.
Whether she's rich
I would know
or
they
poor,
were
it's
November
just
2001. I would have been in
you
second grade
know, like, it's like, bro,
because I would have finished second grade in 2002.
It's what? Are you guys ready to start on Unit 2? The next part of Unit 2? We're going to get into some fun stuff now. So, what is the formula for table salt? You probably already know this. NaCl. So, you know, if you ever want to impress anybody with NaCl, you know when you go to a bar and you have a drink and the drink is sweating? Yeah, and it's really annoying. If you put table salt on your napkin, it won't stick to your glass anymore.
When my husband and I went on our first date and I did that, he thought I was crazy, and I'm like,
I do that to every
watch your
napkin, and
napkin
waiters
compared
look
to
at me
mine.
like I'm insane.
Yeah.
Like, why are you doing that? I was like, because now it doesn't stick.
Yeah, it has a nice little square to sit on, so we can do that. So NaCl is a compound. It's a combination of elements. Now, from your periodic table, remember the last lecture, we labeled the groups. So what ion does sodium form? So it's in group 1, so it forms Na plus 1. So sodium is Na plus 1, and chlorine over here is Cl negative 1. That's right. So that's why you have the formula NaCl, because the positive ion is attracted to the negative anion. So cation, anion. So an ionic bond is an attraction between oppositely charged ions. An ionic compound
is that between the same +1, -1, not +1, -2, or?
We'll talk about that. So an ionic compound is a neutral compound made up of positive and negative ions. I'll give you some examples. So an ionic compound, a neutral compound made up of positive and negative ions. So NaCl is 1, where you have the +1 and the -1. So that's just a 1-to-1 ratio. Now let's look at this. Na2S, sodium sulfide. That is made up of 2 sodium ions and 1 sulfide ion. that kind of address what you were asking? So I'll give you another example. Well, but that's not an ionic compound. Let's do Na3N. Sodium nitride. So you have 3 sodium ions and 1 nitride ion. Because the nitride ion is a -3. That balances out. So that's why you have to have 3 positives to balance out that -3. Ide is a negatively charged ion. So that's always your anion. And we'll go through how to name your anions and your cations. But you caught on to it. So sulfide, chloride, nitride, all of those. But what I'm trying to point out is that all your ionic compounds are neutral. In other words, you're not going to see an ionic compound written with a charge right here. You see what I'm saying? Now you say, well, what are those polyatomic ion things that you told us about? Those are ions. They're just cations or anions. They're not ionic compounds. That makes sense? Okay, so all of your compounds are going to be neutral. Your charges must balance. The ionic formula is the lowest possible ratio of atoms. It's the simplest formula. So if you look on your periodic table and look at barium, find out what charge barium, what group barium's in, what charge it would form, and do the same for sulfur. Sulfur is -2 and barium is +2. Okay, so you see barium +2, I didn't mean to write that 2 so big, and sulfur -2. So you might think it's going to be one of each, BAS. So barium sulfide would have this formula. It's the simplest ratio, the lowest ratio of atoms. So sometimes students, I'm going to teach you a method coming up called the cross and drop method to determine the formulas of ionic compounds. So what you do is you just bring the number down, not the charge, to get the formulas. But you have to be careful in cases like this one, because you get Ba2S2. But that formula can be simplified.
Like a common denominator.
Like a common denominator. So you see how you can divide both of these by 2? And that's how you end up with this. And if it's still not clicking yet, on the upcoming pages we have tons of practice on writing these formulas.
So if it was, I'm just going to throw numbers out, like 2 and 6, it would be nothing on the BA and 3.
Right. Mm-hmm. Okay, so on the next page, when you write formulas, you're going to write the cation first. What's the cation again? Positive charge. So the cation will be written first, and it's not cation. When I first took chemistry, I thought it was cation. So cation. So you're going to always write the cation first. And one thing I'd like to point out, remember in Unit 1, we learned where the metals were and the non-metals. Metals lose electrons to form anions or cations. cations. Good. Nonmetals all right, so nonmetals gain electrons to form anions. So when you're writing these formulas, what you're going to find is that because metals form cations, you're always going to write the metals first. So metals will be listed first, and then your nonmetals. Charges are not going to be written in formulas. So omit charges. Remember, ionic compounds are overall neutral, so you don't have to have a charge anyway. Everything should balance out. The way you wrote your ionic compound should work out. Now the third one might be hard for you to understand until we get into practice problems. You use parentheses when more than one polyatomic ion is present. So I'm going to give you a few formulas. Sodium nitrate. Once you know your polyatomic ions very well, you will be able to see quickly. Sodium is +1, nitrate is -1. So if I had calcium nitrate, I'm going to need, calcium is in group 2, so it's going to have a +2. Nitrate ion is -1. So to balance that out, you're going to need 2 nitrates. So it's going to be calcium +2, NO3 -1, NO3 -1. Now notice, with these two formulas, sodium nitrate only has one polyatomic ion. So it's just Na plus NO3 -1. One polyatomic ion. I did not use any parentheses there. In calcium nitrate, I needed 2 polyatomic ions to get a neutral ionic compound. I used parentheses here. So you might laugh, the parentheses police might come out, on a quiz or something. Just one, only use parentheses when you have more than one polyatomic ion present. And sometimes you'll find that when you're working on these practice problems, you get into a very parenthetical mood. Like you might work on your homework one night and you use parentheses all the time. And you come back the next night and you're like, what was I thinking? I used parentheses all over the place. So just be careful with your parentheses. And like I said, we have a ton of practice problems coming up. So we'll get that worked out.
And so if you had to, like how you showed earlier, kind of how you cross it.
Mm-hmm.
So if you had to reverse it, that 2 would go up and be your +2 for
Mm-hmm.
calcium. And then your, since there's nothing there, it would just be known as a 1, that would be your -1 for the...
Right. So you can do the cross and raise when you're asked to name compounds, and we'll do that too. Okay, so common names to know. The us and the ick. The us is the lower charge, and the ick is the higher charge. So the us and the ick are used with nomenclature when you're dealing with transition metals. And so this is kind of where we link in with the pink and the yellow flashcards. Remember, for iron, you had ferrum. You had this name written. I'm like, why do I need to know that? Or gold was aurum. It's helpful because the common names are based on those Greek and Latin roots. So, ferrous and ferric. These are transition metals referring to the charges. Remember I said the only time you look at the charges is when you're doing transition metals. So iron can have a +2 or a +3. The ferrous is going to be the +2. the ferric is going to be the +3. So ferrous is Fe +2. Ferric is Fe +3. And sorry, I'm writing right there. Okay. So cuprous and cupric, that's copper, that's atomic number 29. So if you look on your periodic table, you'll see 2 and 1. So cuprous is going to be which one? +1. And then cupric is going to be +2. Now on that one, why was the higher charge listed first? They list them and how they appear. Like the more commonly ones are listed first. So you see copper +2 more often than you see copper +1.
On ours, it's listed
Oh, it's listed one.
that-
It's 2 and 1.
The
Yeah.
ones we got
But they're
was one
bolded.
and two.
Yes. Okay. So they.
I think that's for all of them.
Bold, most stables. Okay. So, but this naming, us and ick, the lowest one is always us, the highest one is ick. So I want you to fill in the rest for auric, orus and auric, stannus and stannic, plumbus and plumbic.
Do we have to put the +1 or is it just assumed?
Oh, plus, if you just put a plus without the 1. Yes, you can do that, and I'll know it's +1. So orus is which one? Gold. So orus is +1. Auric is +3. And see how they differ for transition metals? There's not a formula for transition metals. They're always +1 or +3. It could be +1, +2, +2, +3. It just depends on the transition metal. Stannus and stannic. Stannus is 10, remember? So, or maybe you don't. So stannus is 10, is atomic number 50, +2, and +4. Plumbus is Pb, lead, +2, +4. So on the next page, I have a lot of practice problems for you. Okay, so you have 66 practice problems here, which is great because you need all the practice you can get when you're writing formulas for ionic compounds. And I say that not to intimidate you, but just to give you an idea. You know, having this much practice helps you. You see the kind of numbers, I have them written that way because we will name them after we learn how to name. So, and I'll have this, I refer to this later on in the note packet, name compound 1 on page 5. So if you're wondering why there are numbers, but it's helpful for referring to as well. I'm going to do a few with you so that you get an idea. Let's do number 26 together. Now, I briefly touched on the cross and drop. So I'm going to put Mg plus 2 carbonate minus 2 I'll do the cross and drop, and I'm not dropping the charges. I'm just dropping the numbers. So then you come up with Mg2 parentheses CO3 parentheses 2. But what do I need to do? Can I simplify? So I can divide both of these. So it's just going to be MgCO3. No parentheses. So for number 26, MgCO3 is the correct answer. So this addresses several things. When you have just one polyatomic ion, you don't use parentheses. You use the simplest ratio of ions. So we simplified that to 1 and 1. So that's how we came up with that formula. Questions on that one before I do another example? Okay. Let's do 27. So you have Mg plus 2 OH minus 1. Bring down the 1, bring down the 2. So it's Mg OH2. A lot of times, students don't give hydroxide the respect it deserves. It is a polyatomic ion. And if you think about what polyatomic means, it means more than one atom. So hydroxide has 2 atoms. So it's a polyatomic ion. What students will often write for this compound, which is incorrect, MgOH2, like that. They'll forget to put the parentheses because there's more than one polyatomic ion. So that is incorrect. So be sure that you respect hydroxide for being a polyatomic ion. Questions on that one? Okay, so I want you to go through and do the cross and drop on all of these. It is a lot, but it's great practice for you. And then I'll give you the answers. So I'm getting, hearing great conversations, and you guys are working very hard. You're doing excellent. But if you're having trouble kind of wrapping your mind around this crossing and dropping, the reason we do this crossing and dropping is to take care of the math for you. Because remember, ionic compounds have to end up neutral. So if you have a metal that's plus 3, and you have a non-metal that's minus 2, you're going to do the cross and the drop. So your formula would be, and this is not in the elemental symbols, it just stands for metal and non-metal. Metal 2, non-metal 3. So The metal has a +3 charge. So if you have 2 times +3, that equals +6. The nonmetal has a -2 charge. If you have 3 times -2, that gives you -6. So that's how we're getting the math to work out. So when you do this cross and drop, as long as you don't write the charges in your formulas, you will get a neutral ionic compound. Now, parentheses. When do you use parentheses? It's only when you have more than one polyatomic ion. So, number 40, for instance, where you have Fe plus 3, and SO4 minus 2. You do the cross and the drop. You end up with Fe2 parentheses SO4 3. Can that formula be simplified at all? No, because you can't find a common denominator to make these simpler.
And you don't touch the ones that are in the parentheses.
And you do not touch the ones in the parentheses. Because if you change the ones inside the parentheses, you're changing what that polyatomic ion is. And you're doing crazy. And you're playing with a lot more than, the ratios. So remember that polyatomic ion means you have more than one atom in this ion. So when you're looking at the sheet that we're doing on these practice problems from, the ones that are polyatomic ions, I'll highlight. So this one is carbonate. That's a polyatomic ion. Hydroxide ion. Sulfate ion. Phosphate ion. Nitrate ion. And I have one more polyatomic ion. We only have one polyatomic ion that's a cation. What is it? It's ammonium. So the ones that I highlighted, you're going to have to look out for. If you have more than one of those polyatomic ions that are required after simplification, then you're going to need a parentheses. Okay. I'm going to put these answers up. If it's overwhelming for you, don't get completely taken just have an anxiety attack. The answers are online too. If you follow this lecture and then go to that, you'll see it. But I know some of you are curious as to how you did. So you can kind of double check yourself. So look through. If there are any questions, I'd be more than happy to answer them.
How do you come up with this? Not to get too crazy if that's too over.
Um,
I mean, like to where, instead of it just being oxygen by itself, saying why hydrogen, like.
Well,
why
they
it's
found
just-
naturally occurring
Okay.
comment, and then so they recognize that. Oh, you'll see this a lot, and so.
So they just kind of.
Mhm. Mhm.
last iron one? This is number 2 and
3. Thank you. So Fe, NO3. Make it no. Well.
What you wish you could do that with your eyes naturally.
Why did that? Okay, so the light. Trying to figure out if the. No, it automatically zooms in. Taking the light off makes it better. Is that easier to see? Sure. Is that enough?
Yeah.
Okay.
And just like the last chapter, I'm assuming that they have like where they have all those quizzes that don't count towards quiz grade, but for practice they have one column on this.
Mm-hmm. Number 20. Yes. Sorry, just bear with me for just a second. Number 20, you have Ca plus 2, carbonate minus 2. Do the cross and the drop. CO2, CO3, C2. Is that what you got?
Yeah.
But remember that this is the simplest ratio. So because it can be simplified, there's a common denominator of 2. And there's so much to think about, and then you forget about the simplest ion. So, but we're just learning this. So if it's not coming right away and you're making little mistakes like that, it's not the end of the world. I think it's a lot to take. Mm-hmm. Right.
So basically, like if you ever have 2 from each, then you can spread them out.
Mm-hmm. Right. If they have the same charge,
Charge on the top.
just opposite. Same magnitude, just opposite charges. Yeah. And I had students ask, I have blank versions of this on Angel or whatever learning management system.
Minus
Um,
one charge.
So you can you can print it off again if you want more practice.
NO3s and nitrate of iron.
Didn't they hear that they were getting rid of Angel? Are they replacing it with something different?
Desire to learn.
Is it higher for math?
Well, it's supposed to be better, but they're always supposed to be better. It's the same.
Change. Nobody likes change.
When is the change? Or summer. You just got Angel.
Yeah,
Yeah. Number 21. Because hydroxide, where'd that sheet go? Remember, hydroxide is one of the polyatomic ions. So when you have more than one hydroxide, you need to put parentheses around it. Yeah. So hydroxide, it is a unique polyatomic ion because it's just one of each, one oxygen, one hydrogen. It's not one oxygen and 2 hydrogens or, 3 like your other polyatomic ions. So it's very easy to forget that hydroxide is a polyatomic ion. Remember, if you think about what is polyatomic ion, many atoms. So more than one atom together. Any other questions on this?